Nice to see everybody again. Lots of known faces. I've been out of circulation for a few months, so good to see everybody is still, beating that Presto drum, which is awesome. So this one is not really strictly about Presto, and I'll try to keep it relatively brief. I just wanted to talk about a few kind of general things that are happening in the industry and how this impacts us and our technical direction, especially in the long term. Right? By the way, those don't know me, I go by Biswa. I worked on open source stuff at Meta for a few years, and I've been doing data for many years before that and since then. So usage trends and environmental trends, I kind of try to divide this because they kind of evolve a little independently in my view. I think the left-hand side, we are all kind of fairly, I think, attuned to that. Hey, our data volumes are exploding. Surprisingly, they continue to explode. ML has suddenly kind of become very important. How many of you guys have used ChatGPT? All right. It's awesome, right? All right. Yeah. Privacy and security is becoming super important these days. I think we all know about the GDPR and the EU regulations especially are kind of getting increasingly tricky to handle for. Freshness and latency of data, of course, continues to climb. We heard a bunch of people talk about Pinot and why it's important. External facing analytics, same way. Like we have got Rockset, Pinot, Druid, and many other kind of companies try to tackle that space. Data models are getting very complex. I think the BCNF and 3NF days are gone, and whenever we talk about TPCH, it's all flat data, relative joins, standard fact, dimensional model. Like for those of you if you've worked on fairly large scale companies, or in fact any of the recent companies, I think know that data models don't work that way anymore, right? We've got maps and lists of maps and structs and maps of structs and structs of maps, blah blah blah, right? So data models are pretty complex. And query methods are also becoming pretty complex. Now you've got graph query, you've got real-time queries, standing queries, like whatever, right? But at the same time, our environment is kind of shifting around us. Like, so we have got disaggregation, especially storage disaggregation is very, very common these days. Nobody actually co-locates data and compute anymore, like those Oracle days and MySQL days where you buy a machine with a ton of RAM and a ton of SSD and show all your data into that machine and query it. It doesn't do that, right? Nowadays we have S3 and clusters and all that kind of stuff. Horizontal scaling, I think our machines have kind of have not been able to keep up with data growth. So you don't get a machine with 25 petabytes of RAM, but our clusters often have like that kind of RAM. So which means that you have to keep scaling horizontally, more and more machines. Elastic compute. We want to leverage our machines much better, so we have to kind of give, hey, this machine is going out of commission, replace it with that machine. This machine is running a low priority job, so evict that and run another job which is higher priority and all that, right? Power efficiency and in general kind of efficiency is becoming more and more important, and this is kind of driven by the usage trends where we see data exploding, machines not really growing, Moore's law is kind of on its deathbed or whatever, so we have to become much more conscious about efficiency. So, and finally, I think another important aspect here is engineering efficiency. We don't often think of that, but human capital is still worth a lot, right? Especially in this room, I believe. But we do get, like the human capital is pretty expensive these days, especially people who are too well trained to use SQL and run query engines and stuff like that. This doesn't come cheap, so we have to make super linear improvements in how we leverage the human capital. So with that, the most popular trend I think that's happening in the industry today is this what we call open data lakehouse analytics. I think a bunch of us have talked about this before, and I think Steven touched upon it. But fundamentally, if you look at it, like it's a lot of buzzwords out there, but let's break it down and see what it really means, right? What it really means is this left-hand side and the right-hand side. The left-hand side is we have these properties of the system, which is like, hey, our file formats are open. So it's not like the MySQL format or the Oracle format. You have to go through the Oracle query engine in order to get to the data, or Snowflake for that matter, right? Now we have data in Parquet and Org, so you can directly read the data from different applications, which means that compute can be diverse and different from storage, right? The second is, but in order to get to the data, you need to have you need to know where the pointers to this data are, which means that our open metadata APIs come into play. So our metadata that is pointing to this data, whether it is, hey, this table has data in these directories in this format, and here is how the data is laid out, and here are the columns, right? So that kind of data needs to be available through an open API. This is similar to kind of doing a describe query on MySQL, but not really, because now that metadata itself is in a disaggregated MySQL or maybe in a separate set of S3 files for Delta Lake or whatever, right? And then of course storage disaggregation, which means now the metadata is in a different service, your storage is in a different service, your compute is in a different service, and we've got 3 different compute engines working with 2 different file formats using maybe 2 different metadata systems. So it gets complex fairly quickly, right? And that's why the openness is important, because unless these products interoperate, you cannot really choose the right tool for the job. So now you have been given this power that, hey, I can choose my right tool for interactive queries and batch queries and ML analytics, but you can only leverage that power if these APIs are open and these formats are open. So that's kind of important, right? And then we have the diverse set of applications, going to the fact that our complexity is increasing, which means that now we've got batch processing, interactive processing, streaming, real-time data ingestion, machine learning, all trying to leverage the same data. So you have got your TensorFlow or PyTorch, and reality, your data is really the same or similar kind of logs data that you're extracting your signals from, and the same data and coming through the same process, you also want to run interactive ad hoc queries on it. And you also want to be able to run batch processes to create derived tables on this data, or read the data in real time as it flows into your system to create fresher aggregates of this data, so that you can, for example, tell the advertiser, hey, in the last 3 minutes you got 7 clicks from Greece or whatever, right? So it's kind of there is this huge movement toward convergence, which is really driven by this kind of architecture. So here is an example. I stole this from one of my other slides in Meta. I don't know who made it. Maybe Tim made it. I don't know. But fundamentally, this is how I think the very, very simplified form of how the Meta warehouse works, but really majority of the data systems work in this way, which is you have got these services, and we have got this guy, who is the root of all problems, right? There's a user over there. So he is kind of using our services, right? And in that process, we are generating tons of logs, and we are modifying our databases to say, oh, the user changed their name, the user changed their whatever, and the user clicked on an ad, the user searched for this term or whatever, right? So we've got these 2 types of data. We've got this transactional data in databases, and we've got this appendable logs data that is constantly streaming in, and we need to be able to ingest the data into this our open data lakehouse or whatever you want to call it. We need to be able to transform the data on the fly, so we need the streaming engines or whatnot, right? And during the ingest process, we need to make the data suitable for all these applications to the right. Let me see if this works. No? Does it work? Can you guys see this? All right. So this warehouse is this storage plus metadata that we talked about, right? And then we've got this batch processing, maybe Spark. We have this interactive queries, maybe Presto. And then we've got this ML training, maybe PyTorch or whatever, but really they are running on the same set of data and metadata, at least in an ideal world, right? But we're getting there. Now, but here's the problem. The reason why this world is not ideal is because we have got fragmentation up to the wazoo, right? And so here's a simple example. If we've got n different SQL dialects, so you cannot really take the same query that we're using for interactive analytics and just run it in batch, and it will automatically scale to Spark. So you want to use Spark for batch, and you want to use Presto for interactive, but you can't because you have this SQL language barrier in the way, right? Distributed execution, same thing. You cannot really use the same distributed execution engine because your interactive engine has very different properties from your batch engine, right? Even when we come down to the evaluation at the node, now whether it is Presto or Pinot or Flink or Spark or whatever, everybody has written their own eval engine. So everybody has a different set of functions, a different set of operators, or even if they're the same operators, like the simple join operator has n different implementations, one for every engine out there. But reality is that they're really doing the same thing, right? You have got a set of tuples here, a set of tuples here. There is only so many ways that you can join them. You've got the nested order join, you've got the shuffle join with the hash key, and you've got the sort merge join. Really, there's no reason why these code bases are fundamentally completely different, because the underlying operators and functions are really not, right? And then finally, data access. So we have got n different formats. We have got Parquet, Arc, whatever. More problematic is even when there is the same format, you have got n different libraries accessing this format. Maybe because of language reasons, like some of them are in Java, some of them are in C++. Even within Java, there can be fragmentation because somebody added, Arc v2 RLE encoding, and then this encoding was not supported efficiently in Java version 1. So somebody forked that and wrote a Java version 2. And now you're screwed because this guy cannot read this guy's data, even though they both claim to be ORC compliant, right? So we have this kind of problem really across the entire stack, which are preventable if we had maybe somebody had a kind of a magic wand and say, hey, I want to go back 10 years in time, and I know given that open lakehouse is the future, how would I architect it? You definitely wouldn't build it this way, right? You would say, oh, I need a common set of eval functions. I need a common SQL dialect. I need a standard set of operators. I need a standard set of functions, right? I need some common way of shuffling, et cetera, et cetera. So how does this impact us? Obviously, our innovation velocity is poor, right? If you compare ourselves, for example, against Snowflake, like they have got the same engine, same set of eval functions, consistent query dialect, so they can innovate faster, right? And of course, it's a poor user experience because I cannot easily port my knowledge of one dialect to another or whatnot. So what can we do about it, really? The answer is, I think, as with most answers in software, is right, we should kind of componentize, right? We should build reusable shared libraries, shared expressions, shared functions, and so on. So what are we doing? So I think this is the effort that we call kind of shared foundations. And we have been doing this at Meta for a while now. I think many of these efforts have been open source. Let's quickly walk through some of these efforts and how they are hopefully benefiting the community. So now, starting at the top, we have this language, and hey, we want a single SQL dialect. So we have taken the Presto dialect, but now we have to run this in Spark. So how do we do that? So we have a project for that, right? Which is the Sapphire Presto on Spark project, which means that I get the scalability of Spark for batch applications, but I don't have to learn a new dialect. I can use Presto's dialect. Distribution engine consolidation, same thing, like, hey, we have got Presto for running batch, we have got Spark for running batch, what can we share between them? So we'll talk about what can we share, for example, in terms of caching, what can we share in terms of kind of execution velocity and things like that. Execution engine, same thing, like, do we really need n different ways of writing the join function? We probably don't, right? So what can we do there? And our answer there is Velox. This is this kind of common eval library that has the core components for all these functions and operators, right? And then finally, data access. Like, how do we find a set of data access mechanisms that are kind of common and consistent across these engines and different formats and things like that? So a couple of use cases I wanted to go through. The first one, I think we have talked about this a couple of times in previous conferences, is RaptorX. And here the main problem was that we want interactive performance on top of our disaggregated data, but we want the performance to be high enough as if the data was aggregated, right? And the previous solution here was, oh, let's copy all of this data into the local SSD of the machine and create a new data copy and maybe new ways of accessing the data. But really what we are doing now is not very different from that, but now we are using local SSD as a cache instead of as a store. And that kind of opens up all kinds of interesting opportunities. Because now we are saying, I don't really need a separate metadata for Raptor. I don't really need a separate way of partitioning the data. I don't need to make sure all of the data is copied. All I need to do is opportunistically cache the data while the source of truth data all kind of still remains in the distributed file system. So you achieve disaggregation, but at the same time you achieve comparative performance as if the data was copied in local SSD. So I think we have, and this has some other kind of side advantages. So for example, because now the same data can be cached in multiple machines, you can probably do kind of say that, hey, this machine is overloaded. I'm going to send this query fragment to the other machine. So your tail ratings are actually better. Yeah, your data gets cached in slight overlap in caching in the two machines, but that's a fairly small price to pay. And then now we are executing on that further by integrating this through this PrestoStreamer project to kind of go deeper and kind of make the evaluation faster as well. And then, of course, we want to integrate that into our batch processing world as well. So here is a nice example that we are taking the same engine, Velox, that we are using for interactive queries and applying that in batch as well. And the reason we can do that is because of this other project that we have done, which is like take the same SQL dialect, the Presto SQL dialect, and make it work on Spark as part of this Sapphire project. So because we have the same dialect, it's a lot easier for us now to actually use the same underlying compiler optimization or eval engine like Velox and make it run faster. Okay, same here. The next example was how do we get interactive analytics on real-time data. Now, in the old world, if you had to copy your data around into your local SSD, that means that you had to have a separate set of processes. Those processes added latency, they added cost, so it was not really possible to have real-time data into Raptor. And we had other systems, like for example, Facebook has Kuba, that can directly kind of stream the real-time data into the local SSD of machines, but that was a completely different engine with its own limitations and its own copy of the data and its own dialect and things like that. So now, with the fact that our storage is disaggregated, we were able to get real-time data because all we are doing is we are saying, oh, these partitions are open and data is still landing. And when you're querying the data, your metadata now knows that these partitions are open, so I need to refresh the metadata and go do your, whatever you're doing on the real-time system to get pointers to the data. So yeah, you missed the cache the first time, but then onwards you're getting pretty good performance even though your data is continuously streaming in. And you still have the benefits of disaggregated data. Yeah. So here is another interesting example, and this is something that we have not probably talked as much about, or some of these components are not yet open sourced. But one problem that we had encountered that, hey, all of our file formats previously were designed for analytical workloads. But when new ML training workloads come in, does that require a different format? Should we rethink the way the format is evolving? And it turns out that we could build a format that was optimized for both analytical queries and ML kind of training workloads. So if you think about it, fundamentally, the ML training workloads are not that different. You essentially have a huge map of features versus values, and these values are typically integers or arrays of integers, right? And your features are either integers or small strings, and they have a lot of advantages of being columnar because often your training doesn't really require you to read all of the features. Different training models kind of read different subsets of the features. So now we are looking at Arc, and Park can say, hey, how can we improve this to make our training better without compromising anything on the analytics? So it turns out that if you use the right kind of encodings and evolve a new encoding, so we have a new encodings for very deep maps, for example, then you can actually reuse the same file format across both ML training and analytics. And one big advantage of that is that now you can actually do very fast analytics on the same data that you're using for training. So if you want to know, oh, what is the frequency distribution of these particular features versus those particular features, you can run a Presto query on that data. And that query will run relatively fast because you're reusing the same Velox codex, essentially, for reading and writing the data that you're using in your PyTorch-based ML training pipeline. Okay. That was a very fast walkthrough over some of the stuff we are doing. Open to questions. Stunned the room into silence.
So
now, okay,
I have a question about the last slide you showed us, the machine learning. So did you end up making the format like, as far as I know, AWS has the record IO protobuf format. So do you have that kind of, you ended up discovering that format for the machine learning kind of workloads, or?
No, actually the format, and this format has not been open sourced yet, but it is basically just another columnar format just like ORC.
I see.
It has some differences in how the data is laid out and the kind of encodings we have. I don't know if there's anybody from the XLDB team here, probably not. But fundamentally it is a columnar format. It's not a row-oriented record IO protobuf-like format.
I see. So it's not open source. I mean,
this format is not open sourced. I don't know what Meta's plans are, but I believe we do want to open source it at some point. But
okay, thank you. That's what I want.
Maybe Philip can talk about it.
a lot of different technologies were mentioned. Does it give rise to the thought of like how to organize all these different technologies in open source in terms of like how to structure them, how to govern them? Like, there seems to be a very big common underlying theme. And have you thought about, sort of like, that as an opportunity to kind of like do something like what CNCF does with, sort of like.
Yeah, I think that's a very good point. It's definitely the problem we have right now is I think we do have like the Linux Foundation umbrella for Presto, for example. We don't probably have all of these efforts under the same umbrella. And it would be nice to have more, maybe coherence is the right word, so that these things can work together better. I don't know whether the current set of companies have the appetite for that, but I would definitely be supportive of that. I think it will make a difference.
Hi, great talk. I have a question. So when you talked about the language unification, it's funny because SQL is supposed to be standard, and then you have all these dialects because various reasons, but one of them being vendor lock-in. When you talk about commercial database vendors, if we are to design systems that are composable, and we couldn't even agree on a common SQL dialect, how do you think we can agree on API so that all these components can be shared across different systems?
I think you just have to build the best possible thing. But honestly, I think the SQL, yeah, it's kind of ironic that SQL having such a long-standing standards committee is one of the least standardized languages in practice. Like right from the data type to kind of so and I consider the whole ANSI SQL effort to be a failure, to be honest. But I think the truth here is that we don't really have a lot of levers to influence people, especially in the open source. Like you can do whatever you want. You can take the core SQL and fork it and create core SQL 2. Nobody's stopping you. You can take Velox and fork it and call it Velox 2, and which is why. But I think the thing that the lever that we have, I think, is this community, right? If we are determined to say, hey, we are going to be thoughtful about how we are evolving this so that it remains compliant, it remains kind of reusable, the APIs gradually get refactored, and we are open about communicating our plans early and often, and this is a great kind of place to do that, right? And keep the community excited. I think that is the best lever we have. Like why? I mean, essentially don't give people the reason to fork. I mean, some people would still fork because people are like, oh, I'm going to take Velox and use it in my proprietary products and kind of add my old proprietary extensions because then I'm going to sell it for the higher price. I mean, you cannot stop that, right? But at least within open source, if we can avoid fragmentation and if we can avoid forking, the best way to do that, I think, is through kind of making sure that we communicate as a group better and keep each other's abreast of our plans and why we are doing and why this is important to Meta, this is important to Uber, this is important to HANA, this is important to Rippling or whatever. We just need to make sure that we are hearing all of the voices. And hopefully our contributions are available to everybody else so that they are discouraged from forking, because if you fork, then yeah, you can build that better thing yourself, but then you lose the community's contribution, right? So it's a balancing act.
Hey, great talk as usual, Biswa. So when folks think about optimizations, right, they just think largely about like the engine optimization. But you outlined a few of very cool initiatives that you led at Meta here, right? Like, for instance, file formats and Velox and things like that. Can you expand a little more? Also, were there any ideas you wanted to explore which are probably something you see happening down the line?
Well, I think like lower level optimizations are easier to do, but they also have kind of lower returns. Like I think Velox is great and Alpha is great, but if you create a really shitty plan, then it's not going to help you, right? So I think one area where I do feel we have lack of coordination or lack of kind of collective community thinking is around the higher layers of the optimization stack. Like the Presto optimizer is pretty decent, but if you look at what's happening in reality, I think some of the more richer parts of the optimizer, like history-based optimization and stat-based optimization, are kind of fragmented, because the problem is nobody can agree on a clean API on how to communicate history and how to aggregate history and to use that. And I think this is an area that requires thought. I know that some people, like Pedro is not here, but Pedro is kind of very keen on tackling this problem. I think Philip can talk about some of our open source work that is happening in the compiler world, and hopefully that will make a dent on at least creating a framework where these kind of things can be applied. But yeah, the higher layers of optimization, I think, is one area where open source tends to, like our open source components are quite behind the industry, and we do need to pay attention to that, because I do see substantial fragmentation in that space. Going once? All right, going twice? Thank you.